Here is an example of such cases. So the area of a segment A of S, no, of a circle with a radius r, which is this is the A of S, the shaded area, is given by this formula. Suppose we have one unknown. So in this formula, suppose one of these variables are unknown. So what if we let the area and the radius be given? And let's suppose that the unknown is the theta. Thus, the equation has to be solved for theta. Now, the problem with this is that it is impossible to transform the equation, this formula, to solve for theta. So, thus, we cannot solve this problem analytically. However, there is another solution, that is by using a numerical approach. Recall that numerical method is just coming up with an accurate approximation of the true solution. That is exactly what we are going to do to solve this example of finding the unknown theta given these two variables. Okay, so since the equation only has one unknown, which is the theta, um, we can transform it into the form introduced a while ago, which is the f of x equals 0. Thus, by transforming the equation, we have this formula. So we have this. So we just transform this to be equal to 0. So in transforming, we see that our f of x is now equals to this one equals to 0. Okay, now suppose we let the given variable to be, of course, a sub s to be 8 meter squared and our radius to be 3. So if we solve the equation using these given values, we will have this final f of x. So in this final f of x, it is now clear that the only unknown that we need to solve is our theta. Now, if we graph this equation using a graphing calculator or online graphing sites, uh, we have this. No, we have this. So this is the graph of this equation here. And as we can see, the solution or the root of this equation wherein our f of x is equals to 0 is between x values 2 to 3. Okay, so this is the solution, or this is the value of theta that we are looking for. Now, to find what value this is, we approximate, no? We approximate according to the graph that we acquired. So now suppose we let theta as 2.4, since 2.4 is somewhere between 2 and 3. Now if we let theta be equals to 2.4, we have 0.2396, which is not close to 0. It is still far from 0. Now let's continue by finding another approximation of theta that is between 2 and 3. And here we just move a little bit forward. So we select theta as 2.43, and let's try to solve that in the equation. And so as you can see, we have 0.003683, which is much closer to 0 than the previous solution that we have. So since this solution is much closer to 0, we can safely approximate the solution to be theta equals 2.43. So that is all for the example. In the next lecture video, I will be explaining some key points presented in this example that you should keep in mind as we continue on our topic on numerical approach used in a nonlinear equation.